All right, so we've got a few more problems here dealing with quadrilaterals. This first one, an application style problem. We've got Justin Timberlake is adding a 10 by 12 concrete patio to his lake house, which is situated on Timber Lake. He wants to make sure that it's square, right? And when we're talking about square, we mean like having right angles, okay? We don't want some jacked up, weird patio. What are a few ways he can make sure that it is indeed square? Think about past units and this current unit. So I'm thinking the first thing we might want to do here is let's draw ourselves out a rectangle. So let's say we've got something that, it's a 10 by 12, that's about good. Okay. So we got 10 feet and we got 12 feet. So I just drew a rectangle. I know this is a rectangle. How can I verify that it is a rectangle? And I'm not too worried necessarily about doing a whole bunch of math necessarily. Some of them we will have to. But otherwise, just maybe general ideas. Let's talk about our quadrilateral properties, okay? We should probably pop some of those up. So when we're talking about this thing being square, we're really talking about it being a rectangle, like that it has 4 right angles. That's what we refer to in construction when we're saying we want to make sure that it's square. So what are some ways to prove that something is a rectangle? It has all the properties of a parallelogram, meaning the opposite sides are parallel and all that good stuff. The opposite sides are congruent. Maybe we, first off, probably be a good idea to measure these sides, make sure that they are all good. We could do that when framing up, a concrete slab for a shed, for a patio, for whatever. We want to make sure, that those sides are all, or opposite sides are congruent. Okay, but that could still be a parallelogram, right? It could still have opposite sides congruent. Oop, where did my line go? There we go. It could still have opposite sides congruent. These guys are congruent, these guys are congruent, but be kind of slanted like that, and making it a parallelogram. So we've got to make sure that it does have the 4 right angles. And the main one that I'm looking at is number 2 down there. Diagonals are congruent. That's something that we could verify with a tape measure. If I were to measure this guy here, I'd want to make sure that they are the same measure. Okay? So that's one thing that we could write down if this were a test question. I could say measure diagonals, make sure they are the same. Okay, so that's one way that he can make sure. And that's really the main one with our quadrilateral properties. This is probably the most common quadrilateral property that we will use. We could do this when framing up a door. We'll definitely do that when framing up a door. When making basically anything that we want to really be a rectangle or a square. We want to make sure those diagonals are indeed congruent. But we also have to have those opposite sides congruent in conjunction with the congruent diagonals. Otherwise, keep in mind our properties of an isosceles trapezoid. What do I know about an isosceles trapezoid? My diagonals are congruent. That is the exact same thing that I just used for the rectangle. So I have to verify first that it's at least a parallelogram, which is why I measured my opposite sides to be 10 and 10, 12 and 12. Now, when it has congruent diagonals, that makes it a rectangle. Okay? If I just measure my diagonals, it could be an isosceles trapezoid. So we do have to have a couple pieces to that puzzle there. Okay? Cool. I'm going to take that guy out of there. Ugh, that's not, there we go. All right, now it's gone. Okay. So, what else could we do? Let's go out of the realm of quadrilaterals. Let's go back to old stuff. Could you do maybe something with Pythagorean Theorem, right? I could check each and every one of my angles by measuring, say, a 3, 4, 5 triangle. How about that? So we could do a 3, 4, 5 triangle. I could measure 4 feet, 3 feet, and make sure that this is 5 feet, and I could do that on each and every corner of this thing to verify that I have 4 right angles. All right, that's a nice quick check as you're starting to square this thing up, and then measuring your diagonals at the very end. That can be a helpful thing to just get it pretty close to start off. And I think that those are 2 very good ways that we could go ahead and verify this thing for Mr. Timberlake here to make sure that he has a nice, lovely, lovely concrete patio that is square. Excellent. All right, looks like we got ourselves a little algebra problem here in conjunction with our wonderful quadrilateral properties. It says solve for x and y in square A, B, C, D. Now, there are 2 main things that we need to remember from algebra when we head on to Algebra 2 that are a must. It's factoring, which we've already reviewed a little bit of, and also systems of equations. Okay, so I think the first thing is let's get our square properties up here so we can double check those. All right, so I decided to put up rhombus, rectangle, and square since the square takes from those. It also takes from the parallelogram. But let's see what we've got, what we're working with here. So in a square, I know that all my sides are congruent, just like a rhombus, right? I know that my diagonals are congruent, just like a rectangle. I know that it has 4 right angles, just like a rectangle. And I know that the diagonals are perpendicular bisectors of each other. The main thing I think I'm going to be looking at here is that the diagonals are perpendicular. What does it mean to be perpendicular? Perpendicular means that you get a right angle. And what do we know about right angles? Right angles are 90 degrees. Okay, so that is a wonderful start. So it looks like I could probably set up an equation here with that information. I know that 3x minus 2y plus 83 is equal to 90, right? That angle right there is equal to the 90, all right? So this is not really like an application type math situation. This is much more of an algebra type situation that you'll encounter more and more as we go on through this semester and also into your Algebra 2 class next year. All right, let's take a look at this 5x minus 8 and this negative x plus 10y. What do I know about those two? Well, those two are my side lengths, AB and BC. And what do I know about all my sides? All my sides are congruent to each other. They are equal in measure, so I can set them equal to each other. Negative x plus 10y. Okay. So I've got variables, x and y. I've got 2 variables. They're in both equations. I'm going to have to solve a system in this case, all right? So let's go ahead and do that. I'm going to make a little bit more room for ourselves by deleting these properties that we've already used. All right, and then I'm going to go ahead and I'm just going to take these guys, even though that moves that as well, and just move those up there so I can start working with them algebraically. All right, so the blue, let me just recircle some things. The blue involves these 2. And the green involves that guy. All right. So let's rearrange the green one first, shall we? When we're solving a system of equations, we want it to look like this. We want it to be our x's, then our y's, and then we want it equal to a number. So I'm going to subtract 83 to the other side and get 7. All right. And then for the next one, which we'll do in blue, I need to get my x and my y over to the other side. Let me just do that over here real quick, and then I'll pop it in there with my system. So 5x minus 8 equals negative x plus 10y. All right, so I'm going to add my x over. And I get 6x minus 8. I'll do these in a few steps for you guys. Equals 10y. I'm going to subtract my 10y. So I'll get 6x minus 10y minus 8 equals 0, and then I'm going to add my 8 over. And you could do that all in one step. I just wanted to break it down for you guys. Okay, so we get 6x minus 10y equals 8. And again, you can do that all in one step if you feel like it, if you're confident in your algebra, but if you want to take your time, always good to take your time. All right, so we've got all that. Oop, can't do that. Got all that done over there. So let's pop this equation over there in blue. 6x minus 10y equals 8. Okay, so this is our system, these two right here. And I think one of the most common ways that we like to solve systems is using elimination. That was usually the strong suit of most. Well, what can I do to get elimination going here? I need to eliminate a variable. If I were to multiply this entire top equation by a -2, I'd end up with, and I'll put it back in green, negative 6x plus 4y equals negative 14. Everything's got to get multiplied. But the blue one stays the same. So we got 6x minus 10y. Make that more like a 10, not a 6. There we go. Equals 8. So the blue one stays the same, but the green one changes because I multiplied it by that -2. And what did that allow me to do? Well, now I can cancel these two because negative 6x plus 6x cancels out to 0x. I'll add everything else. So 4 and negative 10 gives me negative 6y equals negative 14 plus 8 is negative 6. And when I divide by negative 6, I get y equals 1. So that's one of my solutions. When it said solve for x and y, that's one of them. Well, how do I solve for my other solution? Great question. Well, how about we take one of our original equations that we wrote, or maybe one of our slightly rearranged equations, one of these first two up here, and plug in that y in order to solve for x. That sounds wonderful. Doesn't it sound wonderful? So let's go ahead and move all this. Excellent. It has moved for us. Let's move all that to do a little bit of work down here. All right. I'm going to take the one in green since those numbers are smaller. That's my choice there. So if we take 3x minus 2 times 1, that's going in for y, right? I'm substituting that in. Then I can solve. So I've got 3x minus, well, 2 times 1 is just 2, equals 7. And I'm going to add that 2 to both sides. So I've got 3x equals 9. And I will divide by 3. And I get x equals, well, 9 divided by 3 is 3. So my final solutions are y equals 1 and x equals 3, which we'll often write as an ordered pair 3, 1. That would be solving for x and y in a wonderful algebra type situation. Ooh, love that stuff. And I probably want to go back and double check and make sure that I'm going to get some positive values for this, right? So let's do that real quick. If I plugged in, let me move this whole screen back up just a little bit. I'll write down my solution again for you guys. It was 3, 1. Okay. If I plugged in 3 and 1, if I plug in 3 for x here, I get 15. Minus 8 is 7. That's all Gucci. If I plug in 3, that's negative 3 plus 10 times 1. So negative 3 plus 10 is 7, just like that one. Yay! Checks out there. How about in here? 3 times 3 is 9. 2 times 1 is 2. So 9 minus 2 is 7. Plus 83 is 90. Awesome. A little bit of mental math allows us to quickly check that and make sure it all is good to go. You got to chickity check yourself before you wreck yourself, son. Alrighty. Uno más. Alrighty, so we're going to find the missing coordinates of the parallelogram below. Alright, so we got a parallelogram on an XY coordinate plane. Okay, so we've got my x-axis, we've got my y-axis here, right? We want to figure out those coordinates, the ones that are down here with the question marks, all right? Now, it's kind of weird in this situation because you got like a comma b, we got 0 comma b, c comma d. There's just letters, no numbers. It's kind of strange. So I'm going to go in a little bit different direction here to start. I'm just going to move this guy up here out of the way a little bit so we got some room to work. Let's just say for fun, because math is so much fun, I'm going to go a little bit of random numbers, all right? So let's try to make a little more sense with numbers first. So 0, comma, and then let's call b, let's say that b is negative 2. How about that, okay? And these are going to be random. And then let's say A is going to be, it looks like a negative number. Let's say it's negative 8. All right. And then B we already chose was negative 2, so we got to stick with that. And then we haven't chosen anything for C and D, so let's call that, how about negative 12, comma, and then, or sorry, not negative 12, that doesn't make any sense. Let's go with negative 6, comma, negative 12, right, for my X and Y coordinates. So if you need a little bit of review, remember this is your X coordinate. I've gone 8 in the negative direction, and this is my Y coordinate. I've gone down 2, okay? All right. Well, let's see here. So let's see if we can figure out those missing coordinates if I gave you actual numbers. And then we'll go in that more general sense. So a lot of times in a math class, we'll get in a little more like theoretical or a little just kind of general with variables and see if you really understand the full concept. That's more of like an ACT, SAT style question. Okay. Well, let's see. If I'm looking at this side here, right, if it's a parallelogram, I know right now that it's running horizontal because my y coordinates have stayed the same. Okay, so that's something that you have to notice. My y coordinate has stayed the same. This is a horizontal line. And if it is indeed a parallelogram, my opposite sides have to be parallel, right? I got to think back to my properties. All right, so there's my properties that I have for a parallelogram. I've got opposite sides parallel. So that's the one that I just used right here. Opposite sides parallel. All right, if this guy up here is horizontal, then this guy down here has to be horizontal, right? Okay, awesome. That's fantastic. So I can get, since my y coordinates stay the same here, my y coordinate should stay the same here. Therefore, this is negative 12. But I still need to figure out my x coordinate. Well, how the heck am I going to do that? Okay, well, let's think here. These sides go down at a slant, right? A little bit of a slope to them, right? And same with this guy here. This is going to be doing the same exact thing, right? So I've gone down from negative 2 to negative 12. I've gone down 10, and then I'm going over from 0 to negative 6. So I've gone over 6. I've gone over my x coordinate, which is this guy right here. So when I drop down from this guy, I got to still go over another 6, right? So if I'm at negative 8 and I got to go another 6 over, negative 8 and negative 6 is going to give me negative 14. And that would be my solution for those missing coordinates. Okay, and that's with some numbers. How the heck am I going to do that with variables? That is the trickier question here. Well, let's see. Oops. My bad. Alrighty. Well, I think the first part isn't too bad, right? My B and B stayed the same along that horizontal line, right? Along that horizontal side. So my y coordinate should stay the same here, right? Okay, so I've got D for my y coordinate. But what is my x coordinate going to be? That is a wonderful question. Well, how did I get my x coordinate when it came to the first one? I took my x coordinate from up here and had to head over what this guy was here. So essentially I took these two numbers and I added them together. A plus C would give me that coordinate right there. So it's going to be A plus C. That right there is quite the doozy of a problem in this class. That's pretty much the most math-mathness that we'll get in this class, where we're talking in a very general sense. But let's recap what we actually talked about as far as our quadrilaterals go. The main thing was our opposite sides are parallel. That's actually pretty much the only thing that we use. Opposite sides are parallel means they have the same slope. So if this is horizontal, then this is horizontal, right? So if I go from this coordinate to this coordinate, I went down and over. And when I went down and over, I went over C. So when I went down, I go over another c, right? So I took my a and my c, and I put those together to get my x coordinate. But I was using the fact that the sides are parallel, right? Their slopes are the same. I brought some slope into it. Woo! That was a tough one. That's like a level 4 type question. So if you had some trouble with that one, not the end of the world. That is a very, very challenging question, but I'm happy to explain it to you in a little more detail if needed. America.